Hello, everyone. Today we are discussing on memory cache techniques and mapping strategy on computer architecture. So, first describe what a memory cache is or cache memory. It's a small, fast memory located closer to the CPU and also stores copies of frequently accessed main memory data and helps reduce the latency and then increase performance. Cache memory techniques. One is write through. Writing to both cache and main memory. Simple and reliable but slower. Two, write back. Data written to main memory only when replaced and faster but more complex. Three, cache hit and miss. Hit data found in cache. Miss data fetch from main cache. Cache replacement policies. First, least recent use. Least recent used replaced least recent access data. Second, first in first out replaced older data in cache. Third, randomly select cache blocks to replace. Fourth, most recent used replaced most recently accessed data. Cache mapping techniques overview. Mapping. How many blocks are placed in the cache? We have three types. One, direct mapping. Two, full associate mapping. Three, set associative mapping. So we talked about the three types of mapping. First, we will discuss on the direct mapping. The direct mapping is each memory blocks maps to one specific cache line, and also there is a formula for it. The formula is the block number divided by the number of cache lines and its pros and cons. The direct mapping is fast and simple, and the cons is high conflict rate. For example, when we have 12 blocks uh, over 8 blocks, that is equals to 4. Then we have the full associative mapping. The full associative mapping is any blocks can go into any cache lines. Uses task comparison for all cache lines. The pros and cons. The pros is very flexible, reduce conflict misses, and the cons lower due to multiple comparison. Set associative mapping. Cache is divided into sets. A block a block mapped to a set then can be placed in any line within that set. Example, two-way set associative, two blocks per set. Pros, balance, speed, and flexibility. The comparison table. We have the features, we have direct, full associative, and then set associative. First, I'll talk about the direct associative. The direct associative, the features of it is the flexibility is low, the speed is fast, the conflict missed is high, and the cost is low. The full associative, we have the flexibility being high, the speed being low, the conflict missed being low, then the cost being high. Then we have the set associative, the flexibility being medium, the speed being medium, the conflict miss being low, and the cost being medium. Then summary. Cache, bo- Cache boosts CPU efficiency by storing frequently used data. Write techniques through right techniques through the right back affect speed and consistency. The mapping techniques, the direct full set associative control the memory placement. Choose this strategy based on system cost, performance, and use case. Thank you.